Hello friends, welcome back. Hearty welcome to you. In this session, let's continue with some more examples related to indefinite integrals where we are working on finding out the integral of a functions by using method of substitution. So the basic thought process of solving this type of problems is where we convert the given function into such a way that we have integral of f dash x by f of x, or we get it in the form of integral of f dash x into f of x, so that we can take f of x equal to t, then f dash x dx is substituted by dt. So in this way we will try to solve this particular problem also. So let's have a look at this. We have been asked to find out the integral of e power 2x minus 1 dx divided by e power 2x plus 1. That's what we have to find out the integral of. Okay. Now we want to convert this in the form of f dash x by f of x. So for that, what I will do, if I see here, if I do f of x equal to e power 2x, if I do f dash x, I get e power 2x minus, again I have 1 by e power 2x plus 1, so it's not working out. So we have to manipulate this now a little bit. So for that, what I will do, I will divide the numerator and denominator by e power x, so that I will have e power 2x by e power x minus 1 by e power x divided by e power 2x divided by e power x plus 1 by e power x. This is nothing but equal to, we have dx also there. This is nothing but equal to, after simplification, I have e power x minus e power minus x divided by e power x plus e power minus x dx. Now we have successfully transformed that into the first type of problem, where you have f of x in the denominator and f dash x is nothing but the numerator. So we'll go back and say that e power x plus e power minus x is equal to t. Then differentiate on both sides. You will have e power x minus e power minus x dx is equal to dt. So I can replace the whole numerator by, I can say dt divided by, I can say dt divided by dt, which is nothing but equal to log of t plus c. But what's the value of our t? T is nothing but log of t is e power x plus e power minus x. So that's how we can solve that. So sometimes when the given problem is not fitting into any one of the patterns what we want to look into, or any one of the forms, then we have to manipulate a little bit in such a way that we can get into one of the known format. So we'll solve one more example. Let's look at this example. We have been asked to find out the integral of tan square 2x minus 3 dx. First thing first, what we will do, we will take 2x minus 3 equal to t, so that we can say 2 dx equal to dt. So now dx equal to half into dt, so it becomes half tan square t dt. But we don't know the integral of tan square t, but we know the integral of secant square t. So what we will do, we will convert this as half of secant square t minus 1 dt. That's equal to, now we'll separate them, we'll say half into integral of secant square t minus half into integral of 1 dt which is nothing but equal to, we know integral of secant square x is tan x, so I can say tan t divided by 2 minus t by 2, integral of dt is t by 2 plus c, which is nothing but equal to, t is nothing but 2x minus 3, so I can say tan of 2x minus 3 by 2 minus of 2x by 2, so I can say minus x. I have then constant term, so I can add it to the constant, and I can say that's nothing but equal to tan of 2x minus 3 by 2 minus x plus c. So that's how we can integrate it. We'll repeat that. We don't know what's the derivative integral of tan square t, but we know that integral of secant square t is tan t. So we have written tan square t as secant square t minus 1. Then we have integrated them and we found the answer. We'll try one more example. We have to find out the integral of 2 cos x minus 3 sin x divided by 6 cos x plus 4 sin x dx. Now I see here 2 and 3, I have 6 and 4, so I can take 2 common in the denominator. I will take it out. I will have 2 cos x minus 3 sin x divided by 2 sin x, if I take 2 out, plus 3 cos x. Now you can see very clearly it is in the form of f dash x by f of x, because if you take 2 sin x plus 3 cos x equal to t, if I take 2 sin x plus 3 cos x is equal to t, then I'll have 2 cos x minus 3 sin x multiplied with dx of is equal to dt. So then I can say 2 cos x minus 3 sin x dx equal to dt. So it simplifies to of integral of dt divided by t. We know that it's nothing but equal to half of log t, so we can write it as log of t, which is nothing but equal to half of log of 2 sin x plus 3 cos x plus c. Let's do one more. We have to find out the integral of dx by cos square x into 1 minus tan x whole square. What we will do, we will take 1 minus tan x, whatever we have bracket to the power of something, we will always take it as t. So we will say 1 minus tan x is equal to t. The idea is to knock off this 1 by cos square x as part of conversion. So if I differentiate, I will have minus secant square x dx is equal to dt. Now I can go back and change this as minus of secant square x dx divided by 1 minus tan x whole square, which is nothing but equal to minus of integral of dt by t square. We know integral of t power minus 2 is t power minus 2 plus 1 divided by minus 2 plus 1, that is equal to minus of t power minus 1 by minus 1, which is equal to 1 by t plus c. Now what is the t we have taken? We have taken t equal to 1 minus tan x. Therefore the answer is 1 by 1 minus tan x plus c. So whenever we have we see a problem, we have to look into like what I have to take my f of x such that I can cancel the remaining part as f dash x, so that in the conversion it will become dt and you will get a simple integral function for which you can find out the integral very easily. Let's solve one more. We have to find out the integral of root of sine 2x into cos 2x dx. Now the idea is to find out f of x from the given function in such a way that f dash x is already present. We know that we have square root of sine 2x. We will take, so sine 2x equal to t. That will give me 2 cos 2x dx is equal to dt. So I can go back and say, or I can write down cos 2x dx equal to dt by 2. We have already cos 2x dx. This part I can convert that into dt by 2. So I can say half root t into dt. Now this is pretty simple. We know the derivative of integral of t to the power of 1 by 2, which is nothing but equal to integral of x power n is x power n plus 1 by n plus 1. So that is t power 1 by 2 plus 1 divided by 1 by 2 plus 1, which is equal to half into 2 by 3 into t power 3 by 2 plus c. 2 cancels, you will have 1 by 3 t power 3 by 2 plus c. But the t we have taken is sine 2x, so it will become 1 by 3 sine 2x whole to the power of 3 by 2 plus c. So our answer will be 1 by 3 sine 2x whole to the power of 3 by 2 plus c. So the most important thing is to identify the functions. Once you are able to identify that, then the remaining becomes pretty easy. One more. Let's look at this interesting example. We have to find out the integral of dx by 1 plus cot x. Okay. Now, if I take 1 plus cot x is f of x, I don't have any f dash x, so I'll try to convert this into cos by sine and see how can I get f dash x and f of x same in the function. So 1 plus cos of x by sine x, which is nothing but equal to, if you take the LCM, it becomes sin x dx by sin x plus cos x. So if I take sin x plus cos x as t, then I will have cos x minus sin x, which is not working out. So what I will do now is I will multiply and divide with 2 so that I can convert this numerator into a combination of f of x and f dash x if f of x is sin x plus cos x. What I am trying to do is multiply and divide with 2 so that this becomes half into 2 sin x dx by sin x plus cos x. Then I will try to convert the numerator into f of x plus f dash x in such a way that can I write it as sin x plus cos x plus sin x minus cos x whole thing dx divided by sin x plus cos x. By doing this, it will become 1 plus f dash 1 minus or 1 plus f dash x by f of x. So that way we can solve this very easily. So let's go to the next step. That will be half into integral of 1 dx plus half into integral of sin x minus cos x by sin x plus cos x. Now we will think about this and see what to be taken as f of x. We know generally the denominator. So if I take sin x plus cos x equal to t, I'll write down here sin x plus cos x equal to t, then I'll have cos x minus sin x dx is equal to dt. So I can write down the next step as integral of 1 is x, so I can say x by 2 minus of I have taken minus out, so I'll have minus of cos x minus sin x dx divided by sin x plus cos x, which is nothing but equal to x by 2 minus half of integral of dt by t, which is equal to x by 2 minus half of log t, but log of t equal to sin x plus cos x plus c. So our answer is x by 2 minus half of log sin x plus cos x plus c. So how we have done that? 1 plus cot x is not yielding anything, so we have converted that into sin into cos. Then also we are not getting in the form of f dash x and f of x. So we manipulated the numerator in such a way that we can convert the numerator into combination of f of x and f dash x, taking f of x is equal to denominator. So then we have taken sin x plus cos x equal to t. So then we got x by 2 minus half of log of sin x plus cos x plus 6x plus c. We'll do one more problem. We have to find out the integral of root of tan x dx by sin x into cos x. Obviously whenever we see something in roots, immediately we will take it as x. So that's it's something like a small hint or tip we have from the problem, that whenever we see something in square root, so immediately we will take it as, because we don't know how to do the integral of that, so we'll try to find out other ways to solve it. So we'll say tan x equal to t, we will have secant square x dx is equal to dt. So I'll try to convert this. I will have, first I'll write it down, root of tan x will be as it is, then I'll have sin x and cos x, then I'll have dx is equal to dt by secant square x. Now I'll try to simplify that. It will be root of tan x into dt by sin x into secant x, which is nothing but equal to integral of root of tan x dt by sin x into secant x is sin x by cos x, that is equal to tan of x. So now I can write it as integral of dt by root of tan x, that is equal to integral of dt by root t. Now we got it in the form of dt by root t. Now we'll apply the integral of that. That is nothing but t to the power of minus 1 by 2. 1 by root 2 is 2 t power minus 1 by 2 plus 1 by minus 1 by 2 plus 1, that's equal to 1 by 1 by 2 into t power 1 by 2 plus c, which is equal to 2 into t power 1 by 2 plus c, which is equal to 2 root tan x plus c. So what we have done is we have taken tan x equal to t, then we have substituted. We found that after simplification we get dt by root t. Then we know obviously how to find out the integral of t power minus 1 by 2. That goes by the formula integral of x power n equal to x power n plus 1 by n plus 1 plus c. So that is what we have substituted the formula and we got the answer. Let's do one more. We have to find out this integral of this interesting problem. Integral of x plus 1 into x plus log x whole square by x. First what I will try to do, I will try to separate this x and say x plus 1 by x into x plus log x whole square. Now obviously we know that whenever I see something with square root or to the power, immediately we will take it as t. So I'll write it as x plus log x equal to t, which is, if you differentiate, you get 1 plus 1 by x dx is equal to dt. So it's in the form of now f of x whole to the power of n into f dash x. That means I can cancel this whole part by taking it as x plus log x whole square, and x plus 1 by x into dx is dt, but x plus log x is t, so I'll have integral of t square dt, which is pretty simple, t cube by 3 plus c. So the answer will be 1 by 3 times x plus log x whole cube plus c. We'll do one more problem and then we'll wrap this up. Another tip or hint is, whenever we see a we see inverse, or we see square root, or we see powers, we'll be taking them as f of x. So we'll start with tan inverse of x to the power of 4 equal to t. Then I will have 1 by 1 plus x square, that is x power 4 whole square, and what is the derivative of x to the power of 4? That is 4x cube dx equal to dt. So I have this part is becoming part of dt, or can I write it as x cube by 1 plus x to the power of 8 equal to 1 by 4 dt. Then I will have sine of t. Now integral of sine t is equal to minus cos t, so I can say minus 1 by 4 cos t plus c. That's equal to minus 1 by 4 cos of tan inverse x to the power of 4 plus c. So that's the answer. Let me just repeat that. We took tan inverse x to the power of 4 equal to t and couple of options. One, we see inverse there. Not only that, we see 1 by 1 plus x square here if x power 4 equal to, right. And not only that, x power 4 differentiation is again 4x cube. So we did that. We took tan inverse x to the power 4 equal to t. We got 4x cube dx by 1 plus x to the power of 8 is dt. Then x cube dx by 1 plus x to the power of 8, or I'll write down here x cube dx by 1 plus x to the power of 8 equal to dt divided by 4. So we have substituted that and we got 1 by 4 integral of sine t, which is minus cos t plus c, but t equal to tan inverse of x to the power of 4. So we have substituted that. We have answer as minus 1 by 4 cos of tan inverse x to the power of 4. So in the next session, we have seen in the last session and this session how to solve integrals, indefinite integrals, by using method of substitution. In the next session we will see how to use the trigonometric identities to solve the integral problems. Remember that as of now the only integrals which we know, if you look at all these problems, is we know integral of x power n, we know integral of sin x, cos x, secant square x, cosecant square x, and we know the integral of 1 by x is log x. We know integral of e power x is e power x. Other than that, we don't know much. So we have to manipulate our problems in such a way that they will convert into one of the regular integrals for which we know the process of integration, or we know the integral very easily. So we'll continue with that in the next session. Thanks for your time and support. Bye for now.